Okay, guys, good morning. Welcome back. Unfortunately, 1 week lost, so I'll have to rush a little with you because before the reading week, I want you to do an assignment and also get ready for the midterm exam that will happen after the reading week. So I have a lot to cover, but we'll do it. No worries. I'll emphasize on what is needed for the assignment right now, and then we'll practice more of it when we come back and finish our exam. Okay, so just to give you an overlay, you've already done the for with me. I'll show you how to use a while. You've already done an if with me, so you've seen things. So in the assignment, I don't know how many of you have noticed that an assignment 2 is already up on Blackboard. It was posted on Saturday, if I'm not mistaken, and I've given you a week for it. So starting Sunday morning till Sunday midnight, you have this week to complete it. I will be available for help if required in my office hours. One was today, and I have one on Wednesday and Thursday, right? There is nothing on Tuesday, but if you still want to come and see me Tuesday in between my classes, sure, I am free from 11 to 12, I think, right? Friday, I'm not at work, so you can find me. And weekend, I'm not very sure this time. So try to get as much as you need to know about it before the weekend. So if I get my laptop and I move it around, I'm getting a new laptop on Friday. So I'll be setting it up. So I will not necessarily have Java and BlueJ on it till I set it up. And that's why I say I'm not very sure if I'll be able to help you out on the weekend. I'll make it a point that it's done and finished by Friday, but no promises for the weekend. So please go through the questions, see what you think you don't understand or what you need help with, and you're most welcome to come and ask for help. Okay? If you haven't, I've also asked for flowcharts and pseudocode in that assignment. And I have done something on the board, but today I'll do it officially with you. You can use any free software you like. I use Visio, the Microsoft Visio from its suite is what I have used to create my flowcharts. So what I'll do is I'll start with a very simple flowchart and a very simple example so that you see how it is done. So I'm kind of going back and looking at maybe your second week example you did. So somewhere in week 3, you did a calculator with me, right? So we did a calculator. So you can use up, this was done using Notepad or whatever, but you can always kind of, I'm only showing you the syntax of it, nothing else. So I'll just open up using TextPad. So this was a very simple program that was asking for two numbers from the user, two floating numbers from the user, was doing the sum, checking which number was greater, finding the positive difference, and then finding the product, quotient, and remainder and printing it out, right? So you've done this using straight top to bottom structured programming, no methods, nothing. So I'll show you the flow chart and the pseudocode for this first. And then you've also done this with me using methods, and I'll show you that flow chart. So you can compare the two and see, oh, this is what the difference is. So when there is only one program, top to bottom, there will be a flow chart. When you have program which has more methods, then every method has a pseudocode and every method has a flow chart. But I've only asked you to draw the flow chart and pseudocode for the main method for me in the assignment. I just want you to know that you can, I just want to know that you can do it. Okay, so you will submit me 3 files, unzipped 3 files, .java, your pseudocode as whatever you like, as a Word document, as a text document, as a whatever you like, and 3 flow chart. Again, whatever you like. It really doesn't matter, right? So I'm using Visio because I have it. If you don't have it, it's not free, I know. Use whatever you like. All I have to do is look at it. Okay, so let's look at the pseudocode for this program and then the flow chart. And I've already put this up on Blackboard for you to see. You were not here last week, so the other section kind of, I did it with them. So I had typed it out and I'm just giving it to you so that we can save time, right? So look what I've done. I've written pseudocode is simply just English like. You may not even say what kind of variables you're using. Some users prefer to say float or int or whatever, but it is basically just a set of steps that will be followed to achieve what you want to do. So I say start, input number 1, input the second number, calculate sum by adding number 1 and 2, calculate the positive difference by subtracting the smaller number from the larger number, calculate product, quotient, remainder, print number 1, number 2, sum, positive difference, product, quotient, and remainder. Stop. Done. That's a pseudocode, right? So pseudocode does not use necessarily any kind of syntax of the language. It's just normal English like. So you could, even instead of input, you could say take number from user. You could even say that. I'm using the word input, but you could say take. So it's not necessary to use any computer jargon at all in pseudocode. It's very English-like. Now calculate we all use. Again, instead of print, you can use display. And I'm not saying anything, what kind of numbers they are, or, oh, sum is a double and so on. Nothing. It's just a set of sequenced statements that will be converted into a program when and whatever language you use, whether it's Java or C#. This doesn't change. So there is algorithm, there is pseudocode, and then there is code, right? Algorithm and pseudocode, they differ a little. Pseudocode is English-like. Algorithm starts using some language dependent operators or words. So I could start saying I could start declaring float 1, number 1, and so on, right? So algorithm again is nothing but set of steps and the sequence in which it needs to be followed. And so is pseudocode. So here is an example of pseudocode. Right? Now, if I wanted to draw a flow chart of it, which I have done, I would kind of do something like this. So if you have Visio, you can open it up. There are these symbols here, and most of this are kind of self-explanatory. But for example, let's look at it. I've said start. I've used this symbol, which is called start end. So all you do is you drag it, you double click on it, and you can write whatever you want inside it. There. Right? That's how you use it. And then you can, if on it, you can kind of, it helps you to, I mean, you can take data, and I'll tell you what all these symbols mean because I've used it. But you can just come and you can just drag and drop. If you need connectors, you can use this connector from here. But it is also, it's not showing it, but sometimes it does. That's strange. There. No, it's still not. It automatically, here, there it is. It will automatically show what is the next symbol you want. So you can choose a next symbol if you like right from here. You don't even have to drag and drop after choosing one symbol. Right? So it is so simple. Visio is so simple. I haven't used anything else because I mean, I have this, so I didn't bother to look for free software. But of course, there will be some free software. So now what have I done? I've taken my pseudocode and I have converted it into a flow chart. Right? So flow chart again means what? Flow chart says, oh, the flow of your code is what a flow chart is. Okay, so let's see. So the start has a special symbol. They're elongated. So they're kind of oval shaped in structure, right? So start and end are oval shaped. Anything that's input or output is a parallelogram, right? So if you see it's a skewed square, it's called a parallelogram. Anything that you need for processing means calculating, are squares or rectangles, but straight, right? You could use a square or you could use a rectangle. So notice you have process, you have start end, data means input and output, sub-process I'll show you. Sub-process means calling a method, right? And then you have a decision-making statement. How did I use the decision-making statement? So let's look at it. So I said start, and the arrows show you the flow of the code. Like 1, 2, 3, 4, 10 show you the flow, the sequence, so do the arrows. So it says after you start input number 1, input number 2, right? Again, you can even say it in English, first number, second number, if you like. It can be English, right? Even in your pseudocode, instead of calling it number 1, it made it easy for me to kind of call it number 1, but you could have just said input first number, input second number, find the sum, not even calculate, find the sum by adding first number and second number. So it's absolutely English. There are no rules. There is no syntax. There is no convention. Okay. And the flow chart has convention in the sense that you have to use the right symbols. So that's the symbol for start. Parallelograms for input and output. So you read the first number, you read the second number. Squares or rectangles, but straight, not elongated, for processing. And diamonds for decision making. So after I do the sum, I make a decision. I say, is the number 1 greater than or equal to number 2? If it is, then that's how I calculate the difference. Otherwise, that's how I calculate the difference. So there can be 3 arrows out of a decision making structure. For example, greater than 0, equal to 0, less than 0. So you can have 3 out of a decision making symbol. You'll say, what if I need more? then you can draw two of them, one, and then this false can go to another decision making. The false can go to another decision making. So you can use as many decision making structures as you like to make complicated if statements. But we haven't done complicated if statements yet. So I'm leaving it simple. So I've said, is number one greater than or equal to number two? And that's how you draw it. That's a decision making statement block, right? If it is true, so you put the arrow, and when you double click on the arrow, you can write true on it. If you wanted to say something like greater than 5, less than 5, you can do whatever. So on the arrow, you can add whatever you like. So I'm saying, yes, it is true. So the difference is all of these have come in caps, but I'm not again following any conventions here, but usually I try to draw my flow chart. I keep my variables the same way that I would do it in my program. So since number one is greater, this is what the answer is, number one minus number two. If number two is greater, then you have to subtract number one from number two. So that's always giving you a positive difference, right? Oops, I've missed something. Can you tell me what I've missed? After this difference, I should come back here, right? So what will I do? I missed something. I'll take the connector. And after the connector, I'll join it from here and I'll bring it back to here. So after it calculates the difference, it has to then calculate the product. So for the difference, this is the logic. So that's how you kind of make flowcharts. You can do it by hand if you like. Nothing stops you. You can use any software that's available on the internet. That's up to you too. Or you can kind of do it this way, right? So I forgot, after the difference, I still have to calculate the product. So I calculate the product, I calculate the quotient, I calculate the remainder, and look at my print. Again, it's a parallelogram, and I just say print number one, number two, sum, difference, product, quotient, and remainder. And I notice that I've kept them in small here. So I'll kind of just change these to small letters so that there is no confusion, and put this back on Blackboard because I was missing a important arrow anyway. So I have to put it back on Blackboard. I will. Just because on my print it says these with small letters, I'm just changing them. Or you could have changed them there, whatever works for you. There. And I'll save this, right? And so that's a flow chart. A simple flow chart that shows you the sequence and one decision-making statement. I've only used a decision-making statement. Right? So, and they're all here. It's not a big deal. These symbols are standard. Whatever software you download from the web, when you say I need to draw a flow chart, these symbols will be available. So decision-making symbols, processing symbols, input-output symbols, calling methods, which is called a sub-process, they're all available, whatever you use. So Draw.io, I think, is another one that is available on trial basis. You can download it for a month or something and use it. So whatever you like. Or even if you want to do it by hand, do it, take a picture of it and submit it on Blackboard. But everything must be neat and clean. Okay, so this I'll put back on Blackboard for you. So that's an example of a flow chart. Okay, so now what I'll do with you is I'm going to also show you somewhere where I've used methods so that you have it. Oops, copy and keep both files. Of course not. That's not what I wanted. And I'll make that change on Blackboard. Sorry, I didn't notice it. Okay. Now let's do something else. The same thing, but you did it in week 5 before last week, and you did it using BlueJ. So for BlueJ file, I can double click on this BlueJ and it will automatically open in BlueJ. So you create a folder. If you remember, we create a project in BlueJ. And if you, oh, that's the calculator. Seems like, why isn't it compiled? Okay. I'm just thinking, did we leave it anywhere? No, we completed it. Okay, so what did we do in the calculator? It was the same concept. I didn't change the logic, but I said put everything into methods. So I declared 2 numbers. We talked about local variables and variables that are declared at class level, though I didn't declare anything at class level. I declared some local variables, which I'll talk about today also. I made the program run 5 times. Notice we used a for loop. And then I was calling methods. Display purpose was a method, input number was a method, add numbers was a method, subtract numbers, and then display output. But everything was a method. It is very important for you to understand the use of methods. It's not just that, oh, it's of course, the code has increased in size. But what I'm trying to do is reuse. When you write a method, you can use it as many times as you like in the same program. And especially when you start writing classes, you can create as many objects of the class, and every object uses the same method. Or now also, if you write something and I say, oh, I like that method, can you just send that method to me? And all you do is you give it to me and I put it in my program and I just know how to use it and I can use it. So copy and paste is not a solution. So I'm reading two numbers. I could have just copied and pasted the code and said, read the first number, read the second number, but I didn't choose to go that route. We don't choose that. That's not how it goes. So methods are independent sub-processes. Therefore, you see the symbol of sub-process. So methods are independent pieces of code that are capable of taking input and giving you a result. They have a name. They may or may not have a parameter list. They may or may not have a return value. And what does it make? It makes your main method just nothing but calls to various methods, and then you define each method. But the use of a method is self-independent job doing unit. And don't forget that, right? So if I say write a method, you have no clue who's going to call it and whatever. I tell you what the method should do. That's all you're interested in. So you create a method. I say add numbers. Two numbers will be passed to the method and you have to return me the sum. You don't care who's going to use it. You just write it. Right? You just write the method. You say, okay, I'll call it add numbers. You are saying you'll give me two floating numbers. You add two numbers, you can get a double back. I do the sum and I return it to you. So writing a method is just writing code that has all it needs to know, what do I do? So it is a self-independent job doing unit. And the other uses, reuse. And third, if I need to change anything, I only do in that method. For example, in difference, now I'm only doing the subtraction. But if you say, oh, now I only want to find the positive difference, I'm not concerned about what the other code is doing. I'll go to my difference method, I'll make the change there, and automatically it will work. Because I'm calling it, right? So because now the job has been localized to difference, if I wanted to do the positive difference, the only change is here. I only have to make a change here. If number 1 is greater, do this. If number 2 is greater, do this. I'm not concerned about other methods. All right? So writing methods is important. And therefore, second assignment is totally dependent upon writing methods. For reading input, for processing, for showing output. And we've done it. I've done it with you in this example, and I'll do it again today. Right? So that you get more out of it. Now, looking at this code, I have again drawn a flowchart and a pseudocode for you. So here, I forgot my start, so I gave it a 0. Sorry about that, right? And because it was in text pad, there was no automatic numbering, and I was lazy to renumber them. I just made start as 0. Okay. So what are we doing? We are saying start. I want to do this job 5 times. So I use a counter and I set it to 1. You can say set I to 1, set counting to 1, whatever you like. Set is a normal English word, or you can say give counter a value of 1, as long as it makes sense. So I've said set. So there are some words in pseudocode that kind of automatically become a convention. Input, output, print, set, initialize, increment, decrement. Though they are normal English words, they are used in pseudocode. And once you read pseudocodes, you will kind of get used to it. So this loop, this set counter to 1 is the job that is being done 5 times. We said we will run our program 5 times. So I use a counter 1. I say if the counter is greater than 5, go to 14. 14 means what? Job done. Stop. Right? So here is a go-to statement in a pseudocode, which we don't do in programming. We never write go-to statements in programming. 2 decades back, go to less programming was all over programming world. Everybody said we should write programs that do not contain go to, because it kind of is confusing, right? Go to where? Oh, 14. Okay, there it is. Go to where? So because it takes the programmer's attention, or diverts it, I should say. It diverts the attention of the programmer. Go to programming was a big no-no, and nobody uses it. And that era was when I was doing my PhD. That was my topic of interest, actually. I proved that writing go to less programming was more efficient. It took less time to run rather than the same program and written with the go to. Unfortunately, I couldn't complete it, but I did write a couple of papers and they were published in international things. So maybe when I get old, I'll go back and do my PhD again. But I had to move to Canada, so it's not there. But that was the topic. But here there is no other way. So I'm just kind of writing it, but I'm trying to make it very clear that go to less programming is what we aim at. But in pseudocode, what will I do? I can't do anything. I'm writing it in English. So I'm saying if the counter is greater than 5, you've already done your job 5 times. Go to 14, stop. You'll say, but this will not happen at the first time because you've just set it to 1. Sure, it won't, but it will do sometime. So I'll show you when. No, now notice, I'm saying call my display purpose. I'm just saying call the method. I'm saying call input number to input number 1. Call input number to input number 2. Compute the sum using, see, notice how I've started using the name of methods here. Though you could just write it English, call a method to add the numbers. Even that will do. But changing this code, pseudocode, into flowchart is very easy because the names are written right there. And then I say display the results, call the display output. And notice what do I do here? I say increment counter up by 1. So now counter becomes 2. If counter is less than or equal to 5, go back to 3. Otherwise, it will automatically stop. Right? So here is how you write a for loop in pseudocode. So for loop is what? It's an iterative statement that allows you to do a job a number of times. Right? So we had written a very simple for loop. If you remember the code, it was a normal simple for loop that started with a value of 1, went on till 5, and every time incremented up by 1. This is an example of an iterative statement. So now the program runs for 5 times. Okay, and this is how I write it in pseudocode. Of course, to kind of put it in flowchart, we'll have to do it this way. Okay, so notice what I'm doing here. It's all calling methods. I wish I'll make it bigger and then we'll kind of, then you can see it together. Okay, so I start, I set my counter to 1. So that's a processing. Assignment is a processing. Okay, then I make a decision. Is the value of counter less than or equal to 5? If it is less than or equal to 5, I have to do something, display purpose and so on. But if it is less than 5, I basically have to stop. And I say stop, right? So now I forgot to put my false there. But if I now need to put false, I'll just click on that line. And here I'll put the word false in it. And it will put false. And if you like to move it above, because it's easy if I can see it right above, you can just move it here. Where you said true, you can put false also. Oh, I messed it up now. Where did my arrow go? The false was moving the arrow also. I hate it. Like, anyway, can't do much about it. You move down. You move this side. You move that side. There you are. There. Okay. So false, I forgot the false, and therefore I just kind of moved. I wanted to write the word false. Okay, so I wrote false, and if it is false, you stop the program. So notice from false, where am I coming? I'm coming to. That's what happens when you have to move its head now. Move your head and go back here. There, right? So therefore I did it at home because I know when you start drawing flowcharts, you just have, it just takes more time, moving things here and there. Okay, so where were we? We were here. Oh God. I'll neaten it up before I put it back on Blackboard. Anyway, so there it is. The counter value is 1. Is the counter less than or equal to 5? True. If it is less than or equal to 5, notice instead of that square dark process box, I've started using sub-process. So the method is called, another method is called, another method is called. It's exactly doing what you did in your main program. Then counter becomes counter plus 1. And after that, it checks again. Is the value of counter less than or equal to 5? If it is less, yes, go ahead. If it is false, come out and the program will stop. So how is looping shown? Looping is shown with the help of arrows. So looping doesn't have a symbol. Decision-making statement has a diamond symbol. But looping, what are you trying to do? You're looping, right? So all you have to do is use arrows. Okay, so that's the flow chart for the main method only. So sub-processes are shown by those rectangular boxes, but they have two lines on the end. It says there is something in there. And looping is shown by using arrows. So go back. I'm still using a counter decision box here. Why? Because I said I want to do my job 5 times. So I set it to 1, then I check the value of it. If it is less than or equal to 5, I do this. If it is false, I go and stop my code. Right? There it is. And you can always line them up to make them look a little neat, and you should line them up. But the word false was missing, and you should have it. I mean, I think it's necessary to write true and false. If true is 1, by default, you'll say, oh, the other one is false. I necessarily don't agree. So we'll put true and false. So why does the decision box have 3 coming out of it? So you notice it has a true and, oh, okay. So again, see, this should come from here. And this should come from here. Take the dot and move it down here. Here. So that's false. So why does it have 3? Because you could be having equal to 0, greater than 0, less than 0. So you can make 3 decisions. Here we are only making 2. A true decision and a false decision. So the third is not used, which is okay. It's no big deal. But you can use it. So the false is coming out of one diamond. The true is coming out of the other diamond. And again, the words true and false, I would like you to use them, because it does make sense. And again, I'm trying to do this. I'll see if I can move it up. I'm going to remove it from here, and I'm trying to put it here and see if it works. No, it doesn't. And if I move the whole thing, it starts to kind of misbehave in its, see? Starts to misbehave. So it just takes a little time to get used to it. Now, where is the false word? Okay, so now let's do Control Z. There it is, back to normal. So I have to learn how to move it. Like, I don't want to do it right now. So the aim of drawing these flowcharts beforehand was that I don't waste time in class moving things. But I forgot the false word. So the false is back, and I'll again put it back on Blackboard for you with false. Right? So you have seen 2 examples of pseudocode and 2 examples of flowcharts. And that should be good enough to help you to do the assignment. And it's not rocket science. It's much easier than writing the code in Java. Right? So as I said, if you want to do it by hand, it's up to you. Take pictures and give it to me. I don't mind it at all. Write pseudocode by hand? Sure, do it. Though you have so many editors, why would you do it? But it's up to you. It's no big deal. And again, there are no conventions in pseudocode, but at least write grammatically correct English so that I understand what you're trying to say. So I would stick to input, print, or set, initialize, increment, decrement, things like this, which makes sense, okay? Because we are programmers, these words make sense to us. So when you write a pseudocode, so please see that it is grammatically correct. You can always do a spell check, guys. Word has a spell check, okay? You can always do that. With flowcharts, you may require a little bit of, and again, if you want to kind of make it neat of the same size, all you have to do is just make it of the same size here. That way, everything comes in the same block. I could do a copy and paste, and that way I don't have to do this. When I kind of copy, that was number 1 minus number 2. Oh, what did I do? Number 2. Oh, so I see there is a. Okay, so I see another error. Some numbers was calling add numbers, I think, right? And passing the 2 numbers. And passing the 2 numbers. That's what happens when you try to do things quickly. So again, you can make the same size to make it neat. You can keep it whatever size you want. I mean, I don't want to make them too big to put everything on a single line because it's quite long, but it's up to you. It's as long as we can read it, it is good enough. You'll say, oh, I want everything in 1 line. Sure, do it that way. I mean, just kind of make it longer. That's all you can do. What else, I mean? And again, if you choose one, I usually do a copy and paste, and that was an example of copy and paste. I forgot to change it. So that's, see, don't ever copy and paste. That's why we said don't copy and paste, because then you make a mistake and that mistake is replicated or duplicated or whatever. So your size of these sub-processes can be whatever you like. You can increase this size so that counter plus 1 comes on the straight same line and it looks much neater. Oh, where are you now? That's a kind of an odd one. There you go. There. So you do one small thing and it kind of messes up everything. So you just have to be a little more, see, now it's messed up this one. Hey, God. You'll say we don't like it, but that's, you still have to do it. So there is no option. There is no option. You can move it a little towards the left because it was too, after the size, it was too. And when I do that, then I'll have to make changes here. There. Anything at the bottom? See, it's kind of, it has a mind of its own. There. Hopefully, I don't have to do anything. I did a Control S now. Right there, I'll put it back. So the word false was missing on Blackboard, and it's good to kind of have the right one. So that's a flow chart. So I'm expecting you to draw the flow chart of the main method and the pseudocode of the main method. And it really doesn't matter. If you have to do it for any of the methods, you should be able to do it. But it is in your course that you should be aware of what a flow chart is and what a pseudocode is. Okay, and I'll put this back on Blackboard again for you. Okay, so that was, those examples are available or will be available. They are, but they have a little bit of mistake. So I'll put them and I'll see that I get the right thing to you before I mean, I've already kind of said it's there, but I'll do it for you. Okay. Okay, let me now start the new program that I wanted to do today with you guys because you've missed it. Okay, let's do it. So what I'm going to do today is, again, definitely now we are not going back and writing one straight program. We are always using methods. But what I'm going to do today is a little more of if I get the time, and while. I want to show you a while statement because you will need it in your assignment too. So we've done a simple for, we've done a simple if. I want you to introduce you to a simple while, but that's just introducing, right? We will come back to do more of it after the reading. So the aim today is to write a program. So I'm doing grades. I'm trying to find out the grades a student got in a course, for example, Java, and whether the student had an A grade, a B or C, depending upon some conditions greater than or equal to 90, between 80 and 90. Did the student pass or fail my course? Pass is 60 and above and fail is below 60, right? So I'm trying to do all this, and I'll introduce you to character type, to Boolean type, and to more return types of methods. Okay, so as I do more, I'll add more stuff to programming, and I want to show you the while loop today. Okay, so open a BlueJ, start a new project, save it wherever you would like to. I'm calling it, for you it is week 7 because you missed last week, and I'm calling it grades, right? So that I know that this was the one I did on grades, and I'll go and save it in your Monday section. And there it is. And there it is. And we can close the previous one. So go through the flow chart and the pseudocode again. And if you need me to kind of, explain anything else, please come to my office hour and I'll explain it. Though, look at them once. Okay. Now let's create our class. Let's create a new class. You can call it whatever meaningful name you like. So this one is calculating grades. So I'll kind of stick to grades. We use Pascal naming convention to create classes. Pascal naming convention means every word starts with a capital letter. Every word starts with a capital letter. And that's for class names only. Okay, it's called Pascal naming convention. The language I'm choosing is Java, and we'll do an OK. Open up. Remove everything but the skeleton because we'll do our own work, right? I hope you remember these are Java doc comments. Java doc comments means that they'll go in the manual. So the comments that you see, the help that you see on Java in its API is coming via Java doc comments. Now, I haven't said anything in my assignment yet because Java doc comments are more useful when you start writing classes. You can choose whatever comments you like, simple comments, multi-line comments, block comments, but commenting is asked. And if you have noticed in assignment 1, commenting was one field in which 90% of the class was weak. The code was almost correct for 95% of the class because it was just taking 3 inputs and displaying it, but comments were missing. So I've already given my solution on Blackboard, and please look at those comments for your commenting expectations. Okay. And again, I'll try my best to do commenting as I go on. So what is this application doing? So it says write a description of the class here. We are actually creating an application because we have a main method here. We can say this application takes a student number and final mark, and it can be in any subject or whatever, in Java, whatever, and assigns a grade and status. Status means pass fail. That's what my application does. Okay. So I'm very clear what it does. It takes a student number and final mark of the student and assigns a grade and status to the student. And then of course it displays. If it is small, you can say it displays student number, final mark, grade, and this. If it's a lot of information, you can say it displays student information. Right. So here, if it is kind of small, you can. So in the beginning, we are trying to be more verbose and kind of saying, oh, right. Now in the author, it remains author. You don't change it to authors, even if there is more than one author, because these are annotations which are fixed. If you change it, then they are not converted into the right comments. And it is October 15th today. Okay, so we will definitely need a main method. Signatures of main method: public, static, void, main, can take any number of string arguments. And we haven't yet done it, but we will. Opening of main, beginning of, and closing of main. And since I'm here, I'll say of the class. Right? As and when I require, I'll kind of put in variables and whatever. Okay, so we need a student number. What type? What is a good type for a student number? Just don't think about your student number. It's such a big integer. String. So if Georgian College changes its mind and it starts calling it GC Berry and then your student number, we don't have to worry about it. Now, why don't we use an integer for a student number? Because you don't do any math with it. Do you ever do a math with student number? Do you compare two student numbers? No. Do you add the numbers in the student number? No. So string is a type that is good. Same with phone numbers. Phone number is a number. It's a very big number, 10 digits at least. You'll say, I'll make it an integer. I would highly recommend a no. And you will never find people making phone numbers as integers. Again, why? Because you never do any math with it. More often, you extract the first 3 digits of the phone number to find out the area code, for example. And that can be done with strings. It's very easy to say, give me the first 3 of a string. Whereas if I told you to extract the first 3 digits of an integer, you'll have to write a whole method to do it. You'll have to do math with it. Whereas if it was a string, there is a method available. So remember, string is a class. A class has methods that help you to work with a string type. So there are methods like change all to lowercase, change all to uppercase, find if the string has unju in it, what are the first 3 digits of the string, how many times does 1 occur in the string. There's so many methods in the string class. So somebody has already done for us. Let's appreciate that guy and use his string class. Okay. So even though data may appear to be numbers, don't make them integers just because they are numbers. Think about what is their use. So a student number's use is just identification, nothing else. We never do math with it. So don't make it an integer. String is the easiest to use. String is the easiest to save. String is the easiest to retrieve. for the computer also, and it's the easiest to understand by human beings also. We understand text much easier than we understand numbers, and we don't have to do any math. Okay, so let's declare local variables. And local variables are only available in the particular method in which you're writing them. That is where they're available. So I will definitely need a string for the student number. To name variables, we use camel case naming convention. Leaving the first word, every other word's first letter is capitalized. And it's a good habit to kind of say, what is it? It is the student number. I mean, you'll say, oh, that's the name. And that's the whole beauty of it. If you name your variables meaningful names, then you don't even have to describe them. They tell you what it is. Second, I want to have a final mark. Now, just for the purpose of this assignment, for this example, I'm keeping my mark to be an int. Now, the mark is between 1 to 100. What would be a better type instead of an int for 1 to 100? What flavors of int are you aware of? Byte, short, integer, and long. Byte is 1 byte, short is 2 bytes, integer is 4 bytes, and long is 8 bytes. Do I need an integer? I can do with the byte, because bytes range is minus 128 to 127, and I'm saying the mark lies between 1 to 100. So instead of int, you could use a byte. So try using a byte instead of an int. Now we know that it should be an unsigned byte because marks can never be negative, but unfortunately Java does not have that option of unsigned with their basic data types. With classes, yes. Okay, so we'll call it final mark. You can call it student final mark, whatever you like. I'm trying to write more words so that I can show you the and I'll kind of write it here so that that's what a student can get. A 0 and the maximum he or she can get 100. Right? So I've used a byte. Byte is good enough for me. I should have used an unsigned byte, but unfortunately we can't do that. Okay. Now, what about the grade? A, B, C, D, E, and F for fail. What type of data is that? Is it a string? It's one character only. So you could do with a string, but we have a data type called char. Right? So I'm showing you different types because in the assignment, there are marks for choosing the right type and the right flavor. I've said they will be in your rubric. If it's in the assignment, it will be. That's my next job. I'll make the rubric and put it, if I can, before it is due, but definitely you will have marks for anything that is asked. Next, so character. And now the status, whether the student passed or failed. You could make it a string. Pass, fail are words, right? Again, just to be a little different, I'll use Boolean. I'm trying to introduce you to new types also so that you see, oh, there is where I could use it. So has the student passed or failed? Now you don't have to say a byte to store the final mark, a string to store the student number, a character to store the character. I don't need all those. I don't need what type it is. The type is written right there. I just need to know what are you doing with it. Okay. And that's, I mean, I didn't dock off marks for this in your assignment 1 because at that time I hadn't showed it to you, but that's all I want. And again, it's a good habit if you can put your commenting, align your commenting, because then it's easy to read. Again, small things, but makes it neater to read. So those are your variables, local variables only available to main. None of them are initialized. They all have junk. You can assume they're all not defined. Local variables never have any initial value. Okay, now what do I want to do? What is my job? Think. I want to ask for the student number. Then I want to ask for the mark. Then I want to calculate whether the student has passed or failed my course and calculate the grade. And then display the results. Right? So that's what I have to do. So let's start doing it one by one. The first one, I would always like you to display the purpose of the program. It's always a good habit. So we'll call a method called display purpose. You can call it whatever you like, as long as it makes sense. This method will definitely not require any input from you and will not give anything back to you. It just displays the purpose on the screen. Okay, that's my job number 1. Now I want to get the student number. I don't write input here because I'm not doing an input here, because I'm using a method. I get the student number and I'm going to assign it to the variable called student number. And you can call whatever you like your method. I'm going to call it get student number. Right? Job number 3, get the student mark. Okay, so we know that I'm going to save it in student final mark. And again, I'm going to use a method called get. It just kind of makes sense. And notice, please notice my naming conventions. Get student final mark. Now, if you like, you can pass the student number to it to make it more personal. So there I can say, what is your mark? And I can show the number. If I was asking the name, it could be more personal. What's your mark, Anju? So it makes the message more personal. So I'll take the student number from you and then I will pass it to this method and you'll say, but why does it need it? Just to personalize the message. It makes more sense. I'm saying, what is your mark? And there are 50 students in class. Now they're thinking, who is she asking? But if I say, what is your mark, Brett? Then definitely, no, one Brett J and one Brett G. Then what's your mark, Brett J? Then Brett exactly knows that I'm asking him. That's personalized. So I'm passing the student number. The name would have been better to ask. I wanted to use the number because I wanted you to see, oh, it's a number, but she has used a string. For the simple reason that it is not actually a number that is number in the true sense. Name would have been a better example, but again, my aim is to show you things which don't come as a shock. So again, I mentioned phone numbers, never make them as an int or a long. Int won't even do, you'll have to declare it as a long. Why? You don't do any math with the phone number. And sometimes people write their area codes in square brackets or there's a dashes also. So why are we going that route? It's a string, let's leave it as a string and it will give us more functionality to work with the string. Okay, so get the student's final mark. Your next job. You've got your input. Input is complete, right? Your next job is to check if the student has passed the course. Or you can say, we can say calculate. What should we say? I don't want to say check. I'll think of a better word. And so something will come back to me, and that something that is coming back to me, I'm going to put it in status. So either true will come back to me or false will come back to me. You can call the method whatever you want. I'm going to call the method pass. And again, pass the student number. Pass the final mark. I have to, otherwise how will I check? So this is a necessity. Can I also pass the student number? Sure, if you want to. But I mean, it's not need. I mean, if you want to, here you are saying you want to just calculate something. So there is no message to ask. So there's no personalization of messages. So I'm just doing something. So you can call it calculate pass, or you can say calculate status, but it's not a calculation. It's more of a checking or check status. You can call it check status if you want, right? Instead of saying pass, you can say check status. Here, change the name and it just kind of makes it. And then we will calculate the grade. Right. So again, notice how get and check and calculate words are used just, or you can say assign a grade or whatever. And it's going into the grade variable. Did we call it grade? Yes. You can call the method any good name. You can say assign status, calculate grade, whatever you like. And definitely it will need the mark again. because it is based on mark. The difference between the two, one only returns you one only returns you true, false, and you say, oh, whether it is a pass or a fail. You could have made it a string. I definitely am trying to show you different data types. And the other one is calculating the grade, A, B, C, D, E, and so on, right? So you can get a grade and you can say whether you pass or fail. And at the end of it, display the student information. Again, you could say the student number. What else was there? Final mark, grade, and status. And again, we'll say display student information or whatever you would like to call it. And definitely, I'll have to pass the student number in whatever sequence you want. It really doesn't matter. I have to pass the final mark because I want to print it there. And it's local here. I just can't use it. Anything that's local, I can't use it. Pass the grade. The sequence that you follow here is the same sequence that you must follow there. Oh, and the status also. And I'll do the printing. For now, you know what? Let's see how much I can do. And that's the end of your main. So look how main has kind of become compact. Let's save this just in case. And of course, there are red squigglies everywhere because I haven't written those methods yet. We have a lunch today with last year, the college teachers went on strike. I'm not sure if you know, on October 16th or 15th it was, right? I can't remember, but it was. So they are celebrating the success that we did. And so there is a lunch from 11:30 to, I don't know, something like 3. So in that 20 minutes, I'll go and grab myself lunch, okay? I'll take 20 minutes. I won't be gone forever. But that's the reminder. I should have shut it off. Anyway, there it is. Now, your aim to display purpose, write the display purpose method, the get methods, the check method, the calculate method, and the display student. You have to write all the methods. My main is done. So you kind of put in your head what you want to do. And then once you have it in your head, you can start kind of putting it into words. And I'm trying to copy this because I can just put it in display purpose. Because it's already here, I'm going to copy it from here and put it in display purpose. So making it better there. So let's write our first method, which is called display purpose. So after the main, we'll start writing our methods. So if you like, I can use Java doc comments, though again, these are private methods. So the Java doc comments are not very useful because remember, private means help is not required outside. As you write methods, kind of write their body, put the opening closing bracket, and then start kind of, completing it. So what does this method do? I mean, this method basically displays the purpose of the application. Instead of application, you can use the word program if you like. Of course, I'm going to get an error. It was called display purpose. It doesn't have a star here. And what I copied from there, I'm going to put it here. And that way I can just replace it with system.out.println. Put an opening. Put another system out println here. So that purpose is giving you marks, and all you have to do was just kind of copy it here. Instead of it, we can say a grade is assigned to the course, to the student. Close it here, close it here, close it here. To kind of make it of the same size, I'll kind of make it in the middle. That way it's in the middle. And another thing I'll do is I'll take this and just kind of for neatness purposes. And how long does it take? I mean, you can look at it how it looks. So as long as it remains inside if you're doing things completely, please do them neatly and completely. And there, display purpose is done. Right, so I've kind of put a little so that it comes within. I can put another one and it will look as it is in the middle. Right, that's the display purpose. So the name of the method, display purpose. Does it need any parameters? No. So parameter list is empty, but you have to put the opening and the closing braces. Does it return anything? No. Return type is void. What does it do? Displays the purpose on the screen. Did we need a method for it necessarily? No. Then why are we doing it? Because we know that writing methods is the right approach to programming. Okay, it's a good programming habit. Done. Display purpose is complete. Let's write our second one. The second one is saying get the student number. So you can copy it from here so that it's kind of easy and you don't make mistakes in the name or anything. Again, it will be a oh, don't forget static, because main is static and only call static methods. So writing Java documentation for private methods is really not necessary. Then you write block commenting. You have to write comments. So whatever you are more comfortable with. Okay, so this is returning an int. No, not an int, sorry, a byte. And it is called get student number. Oops, sorry, my mistake. I'm thinking it's the mark. There. So what does this method do? This method basically inputs the student number and returns it. There is no param, but there is a return. So I find Java documentation easier to write because the add return, add param is kind of there. If nothing, if you don't want to do it, only this comment will also do. This will do. Because right now, these are all private methods. And private methods, writing Java doc documentation for private methods is basically useless because nothing is created, right? It's not for the general public. Okay, now what do you want to do here? You want to ask the user. So you want to prompt the user. And then you want to take it and then return it. Okay, so prompt. How do you prompt? You give a system out println print if you like. So if you're asking in the same line, please input, no, you, me, your, us, nothing. Normal. Please input the student number. You don't even know whether you're talking to the student or to somebody in the registrar's office. Who knows who's inputting the number? Right? So you can say, please input your student number. It may not be the student who's inputting it. It could be any user. So the message must be clean and clear is what is important. There is your message. Now you input the number. How do we input the number? We have to need a local variable. Only then can I input it. I can do a return straight away, but I'm kind of going, I'll declare a local variable here. You can call it whatever you like. You can even call it student number. There is no relationship. When you write a method, you can kind of think of writing a method in your own world. You're in your own world, as most of time you are, right? So you can call it whatever you like, and I can confuse you and call it student number, or I may not confuse you and call it student ID. But it has nothing to do with what you called it in the main. It has nothing to do with it. And that's the beauty of a method. You're just writing it independently. So you're saying, oh, I need a local variable. I'll call it student number. I'll prompt for the student number. I'll input it from the user. Then you'll say, oh, I need a scanner also then. Now you can declare a scanner here if you like. But remember, you also are going to ask more things like his mark or whatever. So you need a scanner object that is required not only locally, but in different methods. Now, when you require an object that is used in more than one methods, you declare it here. Though we don't call it global, we call it class variables. And class variables have a default value. So I need a scanner. So I'm going to create a scanner here. Too many n's, too many n's. I'm going to call it input. I'm going to create it right here and associate it with my keyboard. Last time, if you look at one of the programs, I had written in bold letters here, global variables are a big no-no. But this is not a variable as per se. It's basically an object that is helping you to read input. Nobody can change it. None of the methods can change it. Right? So it's like I give you a pen and we all use the same pen. It's like that. So therefore, though it is at the class level, any method can use it. So these are called class variables. And what is this class variables? It is a scanner object, or it is an object, or you can call a scanner object to read input from the keyboard. Now the use of this is you can use this input object anywhere in your code. So it's not local to that method. You can use it in main, you can use it in get student number, you can use it in get student mark, any method you like. So you have the option. Is it okay to declare it locally? Yeah, it was okay. You could have declared it locally and it was fine. Is it better to declare it globally? I would say yes, because it's not something that is vulnerable. It's not a number that, oh, somebody will change. It's not, nobody's life is dependent upon it. It's just an object. It's just a pen to use. It's just a pencil to use. You know what I mean? So just keep it here. I keep the pencil here and I say, and many of you don't have a pencil and you say, do you have a pencil? I say, yeah, use it. You know what I mean? So you can do it here. Why is it giving a red squiggly? Because what do we need to import? My fingers are going too fast today, right? I'm doing many of. Again, you can put a star if you like. You can put the scanner class. So I created a class variable to read input from the keyboard. And for your information, any method can use it, can be used by any method in the class body. So the class body starts from here and ends at the end. So therefore, in other languages, these are also called global variables. Globe means world over. Therefore, they're also called global variables. But the word global is not common in Java. It's not used in Java. We call them class variables because it's an object-oriented programming language. But in structured programming, we used to call them global variables. Okay? And I said, oh, it's a big no-no, never do that. You can declare constants if you like, but I said, never do this. But now I'm telling you to do something, and this is, but think about it. It's like a chair. It's there and anybody can use it. Unless, of course, you're really destructive and you start destroying it. Somebody is breaking the leg and somebody is doing what. But it's just an object that can be used. Okay, now I want to read the final mark. And here is something that I would like you to pay attention to when I read the mark. Okay, how do we read a string? You just take your local variable student number, use that input variable or object that you've created, use the next line method, and your job is done. And then you return them. Look at my commenting. I'm trying to comment so that you can copy these comments with changes. Don't copy my comments if they were to explain something. Like I've said, it can be used by all methods. I don't expect you to write that for me. But yes, a scanner object to read input is what I would like. I'm not asking you to write the conventions for me, class names using convention. No, so when you're copying my comments, please copy them diligently. What you need, only copy what you need. And here you return the number. So what is the statement? Return and the name of the variable. Job done, method complete. So look, an independent method. Like I have no clue. I don't even know who wants to use it. But I was told that write a method that takes no input, returns a string, takes a student number from the user and returns it. And I've done my job. So methods are self-independent units. And that's what they should be. They do a job and they return a value. Right? Okay, now the next one. The next one was the get final mark. And I was taking the student number from, notice this number has already come to me. I can only pass it if it is already available. I can't reverse it. I can't say, oh, I'll first ask the mark and then I'll ask the number, because you're passing the student number to the final mark method. So take this method and write it. No, it doesn't like input. What did we call it? Non-static variable. Oops. Everything that you use has to be static, guys. Don't forget, because it's an application, and since main is static, anything static methods, it's just saying bananas can say hello to bananas. Okay, so it has to be static, and that's what it was saying. I saw an error on the input. So you should be able to read it. Okay, so how do you return it? You go return student number. That's how you return the student number. You use the return statement. There is a return statement. So create local variables, ask the user, take the input, return to the caller. We don't know who the caller is. The next method, get the mark. And remember, the student number was a string. I need that information because I have to put it here. Okay, so let's write another private method. It's static in nature, returns a byte, is called get student final mark, and a string is coming to it. This way I don't make spelling mistakes. So it kind of tells me that's the beginning of my method and that's the end of my method. In the end, you don't have to kind of write the parameter list or anything. Now, what does this method do? It's very similar to what the other method does. Oh, I didn't even complete this one here. Here. Okay, we'll copy it here. Though it's a little different. So what does this method do? This method inputs the student final mark in the course. Instead of inputs, you can use takes if it makes more sense to you. And it does, and returns it for sure. But there is a param also. There is a parameter also that's coming. Param is for parameter. And what does it take? It takes the student number. So you can take the student number from here. You can just copy it from here, write it exactly here. That's the param, right? And what is it? It's the student number. Explain what it is. And what does it return? The student final mark. See how easy it is to just kind of write it. Now again, I haven't said in the assignment that I need to see Java doc comments. If you don't want to use params and returns, don't want to get into the habit of it yet, though I would highly recommend it, just write the first line. This method inputs the student final mark in the course and returns it. If you don't like the word input, you can say takes. You can use take. Kind of input looks odd, sounds odd to many people, and that's okay. That's no big deal. So what's the job now? The job is, but I want to do something. I want you to ensure that the mark that is returned is between 0 and 100. I want you to ensure it. So if the user gives -10, you should come back saying, oh, wrong, please give again. He says 120, come back, no, that's wrong. So the job of this method is to input the student mark in the course and return it. It ensures that the mark lies between 0 and 100. Now the 0 and 100 are magic numbers. They may change to 0 and 50. They may change to 0 to 200. So what I'm going to do is, before even I do anything, I'm going to declare two constants. Remember constants? And again at global level, because if anybody wants to use constants, that's are okay. Nobody can change it. No method can change it. And again, you can make them as bytes if you want. And one, I'll call it minimum mark, convention, all uppercase separated by commas. The other one I'll call maximum mark. And the value is 100. You'll say, why can't we use zeros and 100? Because numbers make no sense, names make more sense. If I started calling you by your student number, I don't think it would be very nice. That's one, it's not nice, but it's not even very meaningful. So instead of calling me your programming fundamental teacher, you could say Anju, and that would sound better and make more sense. is the same thing, right? So what I'm going to do is I'm going to give them names. So these are named constants. Again, there is a requirement in the assignment. The assignment says, I don't want to see any magic numbers in the code. Magic numbers means numbers that don't make sense. And there are magic numbers in your BMI. 703 requires a 703. What is 703? You can just call it BMI constant. Give it a name, BMI constant, and use it. So I don't want to see any magic numbers. These are called named constants. And how do we tell Java that it is a constant? By the word final. So we are specifying it's final. Static is required because of everything is static. It's of type byte. Can take the value 0. You cannot change it now in your program. Nowhere. But you can use the word minimum mark and maximum mark wherever you like. And that's what I will do. Okay, so let's go back to that method. And here is the method. Now, if it was a normal method, when I say a normal method means no checking, nothing, I would have written it like this. So don't copy, but I'll just do it because here, let's change it to something else. Let's not call it student final mark. Let's call it final mark. You can even call it mark to make it easier. Okay, but you can call it whatever. So I've said when you write a method, you have nothing to do. Please input, and again, instead of print, you can use printf. Now we know the student number. Please input the final mark for student number, and then here we'll put a %s, and here after the comma we'll put the student number. And again, the parameter is also local. You could have called it whatever you like and changed its name. I just copied and pasted, bless you. I copied and pasted, so I never changed its name. You can change its name, but guys, please don't go stu-num. I mean, what's the big deal in writing the whole word student? You're not being cool by going stu and num and things like that. It's programming. Let's do it properly, right? NO you think is number, but NO dot is number. Can you use a dot in a name? No. So don't use no. I don't want to read it as stu no. Makes no sense. Though I know what you're saying, but it makes no sense. So when you use variable names, please see that you do it properly. Okay. So please input the final mark for student number this. The student final mark is taken here. The method to be used is next byte. And to return is final mark. And the method is complete. Let's see, we copied comments. So prompt for student final mark. Please use grammatically correct English. Input the student final mark. The apostrophe is after because we are talking of, it's not a plural. Return student's final mark. You can use it before the S also. Both are possible, but grammatically this is the right one here. So it looks okay. And of course, the biggest mistake. It's byte. But have I ensured that it lies between 0 and 100? No. You can give me anything and I'll take it. And I'll prove it to you. So let's prove it. So because before you prove it, you will have to kind of comment out this because it's not available. Comment out this because it's not available. And comment out this because it's not available. So we'll only show the purpose. We'll take the number and we'll take the final mark. And these three methods are ready, right? Let's save it. Oops. Let's save it. Let's compile it. See if we have any compilation errors. No. Let's go to BlueJ. Let's do a right click. Main. Okay. So this application takes a student number and final mark of the student in a course. It assigns a grade and status to the student. How neat is that? Absolutely clean. Now I know why you're asking the student number. And how long does it take? Less than a minute to write that display purpose. So if you're being asked a question, I'm sure all of you will say why. So that's why. That's why. So input a student number. We'll go. You can go anything. You can go Georgian College 1, 2, 3. It's a string. Oops, my C was small, so it came as small. But now the question is personalized. Please input the final mark for student number, and the number is there. So I've made it a little personal, right? Now, because I haven't checked anything, I can give a -12 and it will work. Oops, I can give a -12 and it will work. It doesn't say anything because I didn't tell it to say anything. I didn't tell it that you must check. Oh, did you have this mark? So what is your aim now? Your aim is to ensure that the student is allowed only to input a number between 0 and 100. And what do I require for this? A check. Take the input. Is it correct? Good. Is it wrong? Ask again. Take it. Ask again if it is wrong. Ask again if it is wrong. Ask again if it is wrong. What are you using? An iterative statement. You say, oh, can I say for 1 to 100 and ask for 100 times? No. You've only done for. But is that the right iterative statement to use? No, because you don't know how many times you have to ask. You keep asking till the user gives you a wrong answer. So you don't know how many times. If I say ask 5 grades, 5 marks, then you will do it. You know, the loop will run for 5 times. But here, maybe the person is good enough, listens to instructions, unlike most of students, but listens to instructions. So we'll give the right thing in the first one and I'm ready to go. So just adding a prompt, please input the final mark of the student. It must be a number between 0 to 100 won't help. I mean, I can say it. That nothing stops me. I can say %D here. And that's the whole use. Your messages must be clear. I take a %D here and I'll show the minimum mark, the maximum mark. And see notice how my prompt messages are becoming more clearer. And that's what I mean by complete, clear, grammatically correct prompt messages. I know this is not an English course. I know you're not learning English. But at the end of the day, keep in mind that it's a software that will be used by human beings, right? And it's a software, if it doesn't make sense to the person who's using it, it will die. So when you create something, keep in mind, what are the needs of my audience? Most of you are gamers, right? You play games. Some of you like a particular game, some of you like some other game. Why? For some reason. Maybe its interface, how it looks. Maybe for its instructions. Maybe because it is easy to play. The whole thing is that. So now I've added this to it. So it will say, please input the final mark. It will say between 0 and 100. It will replace this 0 by this minimum mark. I'm hoping for the byte I can use still a %D. Oh, okay. So it is giving me an error. What do I use for a cannot find? Oh, it cannot find the minimum mark. What did we call it? Must have misspelled it. What else? Minimum double M's. Okay, let's save it. I thought it wasn't liking the %D. Okay, so we are good. So I'm going to run this again. And now look at my prompt. Better? Please input the final mark. It tells me 0 to 100. The final mark is between 0 to 100. But if I don't do it, does it say anything? No, it takes it. So your aim now is, so to show the final mark here, I use those two constants. I didn't write 0 to 100 myself. Notice in my code, I could have written 0 to 100 right here. I chose not to, and it is not a good programming habit. I didn't use 0 to 100 here. I didn't write hard code it. It's called hard coding. In the comments, I have hard coded it. Lies between 0 and 100. Because I can't use variables in comments. But here, I didn't hard code them. Why? Now, 1, it's making more sense. Minimum mark, maximum mark in the printf statement is making more sense. And 2, if I change my mind, all I have to do is I go up, change the minimum mark to 10, change the maximum mark to 50, and I don't have to change anything else. You say, but you've only used it once. No, I'll use it again. You'll see I'll use it again. So I've given it a name and I can use it as many times as I like. It has a name, so it has a meaning. And I can use it as many times as I like. And I cannot change it in the run of the code. Right? Now comes the question. I'll give you a break. I know you need a break. In 2 minutes. I just want to kind of see. So this is happening. It's even taking a negative input because I didn't say anything. Now my aim is to ensure that the user gives a positive number between 0 and 100 inclusive. So I'll have to kind of use an if statement. So if the mark is less than 0 or greater than 100, I ask again. But if only does a job once. It only does it once. But I have to do this job as many number of times till the user gives me the right number. So I need a combination of an iterative statement and an if inside it. So the iterative, keep doing it, keep doing it, keep doing it, keep doing it. That's why the iterative. And the if to check, did you give me the right answer? If you did, okay, I don't need to ask you again. And if you did not, I need to ask you again. And that's what we will do. Okay, after the break. Take a break of 20 minutes, come back. I'll be back in 20 minutes. I just need to say hello to a few friends from all over the campuses and I'll be back, okay? And just so that if you have missed it while I was doing it, very quickly, I'll put it in your Monday section, okay? So that you can pick it up. So Monday section programs. So you are on week 7 just because we missed, what am I creating? Items. And I'll replace it afterwards. So this is up on Blackboard, guys, so that you can strange. Yes.
About in the maths class, you have about the quiz 2 in the announcements, right?
Yeah.
So that quiz 2 is from 1.5 to 1.11.
Mhm.
But you have added that you have opened the quiz 2.
Just for today, for people to practice, because we have quiz
does,
2.
Does that carry any marks?
No.
That's
It's just for practice because you have the exam this week and you have, it was closed last Sunday. So I thought just to refresh your minds, so it's just open for today, right? So that you can just, and it doesn't have marks anyway. The exam is whenever I see you next, okay? I know where I'm going. M134.
We're going to do a presentation. Some people like teach. Most people don't know that nowadays. I must have been a great yeah. I mean, like, it's not easy. I had a buddy that knew how to sing, plays electric music, bass, drums, piano, like he knew how to play all these, and saxophone. Like, and he knew how to play silent dance. What was that song called? Careless Whisper. Yep. Yeah, he's for that's for our house band. He played that. It was so fucking funny. And it was I just think of I just think of Emilio.
Downloaded it the first day. I was like, this is fucking horrible.
Well, I started off with Python switching just because like a lot of like I learned a lot of stuff. My friend did good for you.
I don't know what. Whenever I noticed that one, it just crashed every time I said it. Yeah. Yeah.
That's why the arrows show. It's not like an IDE where it's sensitive. Like those look like so I don't even use it.
Yeah.
It's, that's what it's doing. I'm used to it.
Yeah.
I'm just going to see.
Probably. I'm sorry, I was up that late before the morning, just first thing I thought. Not great. Wasn't the best choice.
I don't know. I tried next time. Oh, I see what you're doing. Okay. Yeah, see what I did. I just did.
Like reading week, are we supposed to be getting big assignments during it, or is it literally just a week on? Putting myself on my use of. Yeah, me too. I've got a couple things that I said about. After so it's not like I'm going to be going anywhere, but it would be nice to have one of those times. Yeah, it's like this class pretty much get told how things work. But then, thank God in our Arduino, of course, it's like, here's the thing, they use it if you need help, I'll help you, and then learn all sorts of crazy stuff just right away. It's like, oh yeah, I get it. Everything you need is online. Like, it's here. Hey, how do I do this? No, it's like, The water thing is like a requirement for programs in the future. There's just me sure if you're making a program for users, whatever. I don't think users need to that fix that. I just comment every line that has something super obvious.
Student balance, remember?
I think kind of safer, but at the same time, what thing are you going to call student no as a variable? That there are. Yeah. I like the easy students. Which, oh my god, it's like you get halfway through writing your program and it crashes. No,
I don't know. They look very actually.
And she's like also like streaming.
This is got a computer. Computer game. The only thing that's split is
alright, so I think that Blue Jay, a program written over programs would probably be next page.
it's like they're working. They'll just have to start at the roads.
When I bought this, when I first bought it, I thought the same thing. Also, like, regular those games, but I heard that. So it's like a regular RPG, you know, for the most part. It's just good place to be safe.
To get student.
Yeah. But like, instead of like, now it's in this one.
You just take a look at this for a second and see if you can help me out. So I have enters the gender, it takes the gender, finds the next, but it's still lowercase, it takes the first letter, and then it checks if it's an M or an F. I have it's printing as M, but it's still saying it's a vowel. So is there some sort of logic error here?
Yeah, because all you're doing, oh, you have done it in lowercase.
Yeah. And I was gonna just kind of loop it just to make sure they're actually
Yeah,
entering
but look at something. The character head function is used with the string class, but you're just scanning it. So you should scan it here. Scan next to it. That's it.
Okay.
Right? You
So if they type in, so what I was.
Oh, so you were
if they
doing
type in
if
male,
male,
it would come in here. And that's why I was confused. It's not working.
why? Oh, gender is it's a character, not a string. Okay, so that's not the reason.
I was thinking next, like I had next.
Next with something, yeah. No, next line is no.
Yeah, it wasn't working.
No, that's the reason. No,
Yeah, it was just crashing.
it will because gender is a character, and next line says read till next.
Yeah.
So something is not sure. It's printing out. It's printing out M, but it still says it is invalid, right?
Yeah. It's still going on.
The loop is not. Okay. So by
That's what I was thinking, maybe.
Okay. If I use an OR here, let's see. So you input an M. It's not equal to it is equal to F. That's a true condition.
That's why I was confused.
I'll have to look at the next. If the problem is something to do with the next method.
Okay, so I'll look up.
Yeah,
See if I can find
it's
it.
nothing else. The logic, yeah, something to do with
But
next
the
step.
logic, the while loop looks fine.
Yeah, while
Okay, thank you.
I remember you saying something about this that says for the input, you were saying something about the non-static variable.
Yeah, so non-static cannot be different from a static context. So this student number is a local variable. This is not the variable that's in the main. So declare a local variable student number inside here.
That method,
Yes.
okay.
And what it is saying actually is that if you want to refer to the student number of something else, that's a static. So that's what it was saying. But you cannot do it because if student number is declared in main, it only belongs to main. No other method can use it unless you put it outside in the class variables, which we are not learning, which we should not do.
Yeah.
We should not do.
Yeah,
Okay?
that's more good.
Yeah.
So the example that you put from last Tuesday's class.
Solution?
Yeah, the solution. Yeah.
Okay.
Yeah, I think I don't know if you noticed or if it was intentional, but when you were doing like the grade system, like A, B, C, D, E, or F, something, D, F, it was all just a big comment, so it wouldn't actually display.
I haven't yet finished it.
Oh yeah.
Yeah, Tuesday section, I haven't finished that code yet.
I'm not sorry. I just thought like it was just did a big statement.
No. If it is, I haven't finished it. We still have to finish it. We didn't finish that class. That class will be finished tomorrow.
Okay.
Right? So I'm trying to do it faster here so that I can finish it. But if I'm not able to finish it, that's okay. But they haven't finished it. They haven't completed it. Okay? We'll come back to it. Okay?
Okay, no problem.
Okay. Oh God.
I have no idea. Probably not
Somewhere there was a problem, right? I forget what. Okay, so let's come back to doing this now. One of the important things. So get the student final mark and ensure that it lies between 0 and 100. Now, we've seen one iterative statement in Java, which is the for statement, which actually is usually used for doing a job a certain number of times. Though I could use it here too by some kind of manipulation, but a better loop to use is a while or a do while loop. There are two more loops in Java. The difference between the two is this. So one says while the condition is true, do this. Makes complete sense. So while it is raining, sit inside, right? The other one says do while. So it's just how you write it. So the main difference is the while loop first checks the condition. If the condition is true, goes inside the loop. The do while loop will at least do the code once and then check the condition and then do it. So that's the difference. So I'll kind of write it here so that you can see both of them. And then you can choose to use either, and I'll tell you what the difference is. So the while loop is while the condition is true. Keep on doing this. So definitely the condition you are checking here must be a valid thing. So if I'm saying while x is greater than 5, so x must have a value here. It should be a valid integer. Should have a valid value. Only then can I say while x is greater than 5. Makes sense? I mean, you can write a condition and use a variable which is undefined. The other one says, so it checks the condition. If it is true, goes inside. If it is false, comes outside the while loop. Stops it, doesn't do it. If it is not true and goes inside, it goes back again. Maybe you did something to x here. You made it x plus 1. So you did something to x, it changed, right? So it will keep on doing this. But while the condition is true, keep on doing this. When it becomes false, exit the loop. So the condition is checked before the loop is ended, right? A sibling or a friend of the while loop is a do while loop. Same thing, do while the condition is true. But there is a major difference here. Here, since the condition is checked before the loop body is executed, whatever you are using here, this condition must hold. Hold means it must exist. Like if the variable you are using x, then x must exist. Here, what you can do is you can say do while, and you can take the value of x here inside it, and then you can say something like while x is greater than 5. Because the condition is checked afterwards. So the do while loop is executed at least once, we say, because maybe the condition is false and it will come out. But for the first time, it just enters the loop, does whatever you tell it to do, then checks the condition. If the condition is true, goes back. If the condition is false, exits. So it's a looping statement. So you could use while here, you could use do while here. The difference is if I use while, I have to read the final mark before I say, oh, you must lie between 0 and 100. If I use a do while, I can read it and check it afterwards, because you definitely want to read it once, right? You definitely want to read the mark once. So let's kind of talk it in English without saying anything. What do you want to do? You basically want to do while. What's your condition? What's the condition? Your condition is if my mark is less than 0 or greater than 100, I must keep asking. Right? I must keep asking. So do while the final mark is less than 0, and now I have to add another thing. So I need another, I want to say an and now. So let's introduce you to Boolean operators in Java. And the and is this and. Okay, now read it in English. Do while, do this, do what? This, whatever is inside this do. Do all this while the mark is less than 100 and greater than, or the other option is or. You have to tell me, should I use an and or should I use an or? Or, because you're saying it is less than 0 or it is greater than 100. Okay, so what I am introduced to here for your information is the or operator. And how do you think it works? It just works in English, like we speak it in English, right? If it is raining or it is dark, either one of them is true. Don't go out, right? That's exactly how our or works. It's one of the conditions is true. The compound condition is true. So what you are seeing here is a compound condition. Why compound? Because it has more than one conditions. And conditions are joined by the help of either or, which is that symbol, two pipes, or and, the two ands. Though there is also a single and a single or. For now, we'll just kind of not talk about it because we're not going into details. But this or says, checks what? Is the final mark less than 0? True. Oh, if this is true, I don't even have to check the second condition, because if one of the conditions is true, the loop is true. If the first condition is false, then it checks the second condition. Is it greater than 100? Oh, yes, it is greater than 100. So go back. So this or is called the short circuit or. Short circuit or means as soon as it knows whether the compound condition is true or false, it doesn't check the rest. It says, I'm not stupid. I know the answer. Why am I checking the other conditions? Right? So this is called a short circuit or, for your information. The single or, the single pipe is called, it's not called long circuit. It doesn't have a name, right? But that or will check all the conditions and then make a decision. So when is or true? In English, normal in our daily lives, when is or true? If any of the conditions is true. If you have money, or a friend is going to treat you, or if the coffee is free, drink it. So if either any of these conditions is true, you will have a coffee. So if you have money, sure. If a friend is treating you, so you are getting the coffee, sure. Or if it is free. In all three cases, in any of these three cases, you will drink the coffee. So either of the conditions is true. So you can have any number of conditions combined together by the help of Boolean operators or logical operators, they are called, which are and, or, and the third one is not. Not just reverses it. It's not basically for combining conditions. It just negates the condition. True becomes false, false becomes true. Right? So for now, and or is what we are concentrating on. Now, which one to use? You want to say, like you want to say in English, if you're giving me a mark less than 0, or you are giving me a mark greater than 100, you have to give it again. That's what you're saying, right? Think about it. If you're giving me a mark less than 0, or you are giving me a mark greater than 100, you're giving me something wrong. Please give again. And that's exactly the loop I've written. I've said, do while the mark is less than 0 or greater than 100. But what do you want to do? You want to exactly do this. Keep on asking for the mark. So you prompt, you take it. If the mark is less than 0 or greater than 100, it will ask again. If it is within range, it won't ask again. But now the problem is, how will you know why is it asking again? So you can always give an error message. Oh, your input was wrong. So let's try this. So without any messages, what have I done? I've taken what you had written and I've put it in a do while loop. This is called a do while loop. And the OR operator is the double pipes, they are called. And this loop will execute. This is called a loop or iterative statement. This loop will execute while the condition is true. And you don't have a single condition, you have a compound condition. Okay? And it at least executes once. You'll say why? Because see, when it enters the loop, there is no condition to check. So it will definitely enter the loop and then it will check the condition. So for us, this is a better loop than while because we have to ask before we want to check. I can write its while friend also, and you'll see I can do that, but it is just a little more work, but I'll write it for you, right? So this loop will execute while the compound condition, whether it's a simple condition, whether it's a compound condition is true, and it executes at least once for sure, irrespective of whether the condition is false or true. At least once it will execute. So it will enter the loop. It will say, please enter a number. It will take it from you. If it is right means it is not less than 0 or it is not greater than 100, it won't ask again and it will be out of the loop. If it is outside that range of 0 and 100, it will go back and ask again. The only thing is the user will not know why. So if you like, you can give the user an error message, which is a good practice because it's keep on asking. Why is it asking? Because you're not paying attention to that 0 to 100 and that's why it's asking. So you can give an error message if you like, which we will, which is a very good programming practice because nobody wants to do things if not told the reason. But let's see if it works first. Okay. So now let's see whether this method works. All I did was I used a do while loop because it was just natural to say, oh, do while the mark is less than 0 or it is greater than 100. And I'll give you another example of while also, but let's try this first. Let's see if it works. Let's compile it. Let's go to BlueJ and let's run it. And we will do exactly what we were doing. I'm going to input the student number. I'm going to put in a mark of -12. It's asking again. I'm going to input a mark of 101. It's going to ask again. I'm going to put a -4. It's going to ask again. I'm not putting it in the range. So it's asking me over and over again while the condition is true. What is the condition? Mark is less than 0 or mark is greater than 100. Make sense? As if you would say it in English. If the mark is less than 0 or greater than 100, keep on asking. Now give it within range. It stops asking. So I have forced the user to give me a mark between 0 to 100. And in your assignment, I've said the age of the person lies between 1 to 123 or 24, I forget now, or 150, whatever it is. This is how you will ask. Now, the only thing that is not like so obvious is why is it asking again? What did I do wrong? Right? So what you did wrong was you weren't giving it in 0 to 100. So if you want to make it better in this sense, tell the user you can put an if here. So many users will kind of programmers will put an if here. So we'll spit out an error message. We'll spit a message. So how do you spit a message? You will say if the mark you are giving is less than 100 or 0 or greater than 100. A normal if statement. Remember, if is not an iterative statement. It only checks something. You will say if final mark is less than or equal to greater than 100, then you can give a message to the user. What message would you like to give? You can say something like, let's do a system out printlf. We can say something like invalid mark. Kind of make it like this. And And we can say it should lie between and again I'm going to use that, and you can say inclusive. So now what? Again, I'll use a printf, and I want to show two values. So see, I've used my magic numbers twice already. Since it was called minimum marks and maximum mark, I'm going to copy it from here. I'm going to put it here. I'm going to put a closing bracket, a semicolon, change my println to printf. And I'll have to put a percentage n here also because printfs don't automatically go to a new line. And I'll put a percentage n here also because they don't go to a new line. Because when you use f, you were okay if it was only being asked once. But now, oh, the next byte was taking it to a new line anyway because you were doing enter. But now you'll have an extra line. I didn't need it here because when you enter, it automatically goes to a new line. But now it will display an error message. If the mark is less than 0 or greater than 100, system out printf, invalid mark, mark should be in the range 0 to 100 inclusive. There. So now you will see an error message and it will ask again. So now it makes more sense. So you cannot use an if here because if only does a check once. You need to keep on checking and checking over and over again. And you will do that with the help of iterative statements. So you have 3 iterative statements in Java. For, you've seen a flavor of it. Do while, you just saw it, and a while. And I'll show you while also sometime. Don't worry. As I'm saying, I'm not rushing things because we are just kind of looking at things one at a time. Now let's see, does that make the user experience better? When I say user experience better, does it make more sense that you're asking me more than once? Let's see. So I'm again going to try. Give my student ID, give a mark of -1, and it says invalid mark. Mark should be in the range 0 to 100. Makes sense. That's why it's asking again. Right? That's why it's asking again. So 23 and it won't ask again. Their job is done. So does that make sense? That's one way of ensuring that the user is giving a mark between 0 to 100. But that's not, if you give a 23.5, it will blow up. Why? Because you're saving it in a byte. So this is first step to validation. But this is not the only step to validation. Input validation would have been if I gave Anju, it would say, oh, that's not a mark. Or if I give 23.5, it would say, no, I need an integer. That would be more validation. I'm still sticking to only giving integers. You've asked for 0 to 100, I'm just trying to go out of range. So I'm validating, but I'm only doing one step of validation. I'm not doing complete validation. And when I say complete validation, this is what I mean. If it was complete validation, then it would have also said something about this, which it won't. It's asking me a mark, but users never listen. Oops, it blows up. You said, I asked for a mark and you're giving me an AA. That's not a mark. So that won't take care of that. The only thing I did was that it was greater than or equal to 0 and less than or equal to 100. That's the only thing I've taken care of. Okay. And I've used a do while loop for that. I'll show you the while loop, but I want to kind of try to finish things first so that you have everything for your assignment, and then I'll do the extra stuff. So that's how you will validate the age of a person. If I'm not mistaken, I think I've said ensure that the age lies between 1 to something. So does that make sense, the do while loop? It's simply a loop. It will keep on repeating till the condition becomes false. So while the condition is true, it will keep on doing it. So while the alarm doesn't go off, keep sleeping, kind of stuff, right? And this is a do while loop. There is a third one, we haven't seen it. So we've seen a for, we've seen a do while. The do while checks the condition at the end of the do body. So it will execute it once, check the condition. If the condition is true, go back and does it again. Still true, go back and do it again. Still true, go back and do it again. False, get out of the loop. And came out of the loop when I gave a value like 23. Makes sense to everybody, right? So this is a do while loop. So now I can ensure, oh, you can never give me a mark that is less than 0 or greater than 100. You can give me a 23.5 also. That will also blow up because I've said my data is a byte, and byte means a small integer within the range minus 128 to 127. So if this loop was not here, I was able to give negative values. But if you went out of range, that was a different error altogether. You can't give 150 because that's out of range. So we are not talking about all error handling yet, guys. But I'm saying that I've ensured that the user can give a value from 0 to 100. And I'm done. You can give 0 to 100 and always check your extreme conditions. So can I give a 0? 0 should be acceptable. Yes, 0 is acceptable. Doesn't ask again, right? Can I give 100? These are called extreme. The off by 1 errors can happen if you don't check the extreme conditions. Yeah, so 0 and 100 are working and we want it to work. So be careful what I've used. I've used less than 100, less than 0 or greater than 100. I haven't said less than equal to 0. So what you have been introduced to new today, a new structure. I've introduced you to the byte and to the Boolean, but I haven't to a new structure that you're learning today is the do-while loop. The do-while loop executes while the condition is true. The condition is checked at the end of the do-while body. It's called the do-while body, right? The condition can be simple or compound. Compound conditions are created with either by using an and or by using an or. And says all conditions must be true to make the compound condition true. Or says any of the conditions can be true to make the condition true. Normally English, right? So if you have money and Tim Hortons is open, only then can you have coffee. Right? So and says every condition must be true to make the compound condition true. Does the condition always have to be compound? No, it could be a simple condition. Do while x is less than 5. Right? So I have created a compound condition with or, and it's exactly as we say it in English. Do while the mark is either less than 0 or greater than 100. What do you do? Keep on asking, keep on asking, keep on asking. So write it in English and then convert it into Java. Okay, we've done one job. Now let's look at the next one. The next one said, which we had commented out, it said check the status of the student. Now this check status is returning a Boolean value. You'll say, how do you know that? Because status is a Boolean variable. That's how I know it. Okay, so let's try to write this because I want to show you something else now. You haven't heard true and false ever yet. Okay, so let's write another private static method returning a Boolean value. And notice the sequence. I can pass it a student final mark only if I have a student mark. So the sequence has to be important. Ask the mark and then say is the student passed or failed. You can't say, oh, you've passed or failed without knowing your mark. So I ask the mark first and then I say, did you fail or did you pass? Okay. So look at the signatures of the method. Okay, what should it do? So this method basically, again, I am doing Java doc. You can do normal comments. So this method takes the student mark and you can write it in comments. It is a mark between 0 to 100 and returns true if mark is greater than or equal to 60, false otherwise. False otherwise automatically means if it is less than 100. Oh, sorry, less than 60. Make sense? So this is what the method does. It takes the student mark and returns true. And remember, this is also a local variable. And what is its type? Byte. So anything in the parameter list and anything between the closing and opening braces of a method are local. Nobody outside can look at them. So if you want to use something of the main, you have to pass it as a parameter. Whether you pass it in the same name or whether you pass it in a different name, it really doesn't matter. Here it's called final mark now. How does it matter what it is called? So therefore, I'm trying to keep same names. I'm trying to keep different names to confuse you utterly. I want to confuse you to such a level so that you can understand why and where things are being declared and where and why they can be used. That's the scope. Anything that is declared between the opening and the closing braces is its scope. That is where it can be used. So if I declare something in the beginning, at the class, after the class opening, I can use it throughout the class. If I declare something inside the main, I can only use it in main. Nobody else knows about it. Okay? Okay, so now what do we have to do? This status, so this check status is going to take a mark, is going to check if the student failed or passed, and then it's going to return a Boolean value. So it's not returning pass or fail. If that is what it was returning, the return type would have been string. You could do it. I'm just doing it a different way. You could say, oh, return pass, return fail. Why not? You can. But I am doing it because I want to show you that what is a Boolean type in Java. Okay. Okay. So what is your param? Your param is called final mark. That's what your param is called. Write it right here. And what is this? It is the student's final mark in the course. That's also what will happen with you at the end of the day. What does it return? It returns true if the final mark is greater than or equal to 60. False otherwise. Make sense? So notice if I read the comments are good enough to tell me what the method does. So if I give you comments, you should be able to code the method. If I give you the method, you should be able to write the comments. Vice versa. So I may only give you this in the exam, and you have to fill this in. You'll have to do it yourself. Oh God, what did I do with check status? Whose is this? Somewhere it came from somewhere. Oh, this is here. Okay. You are here, and you are here, and there you are. There. So I may give you a skeleton program and say fill up the blanks. So you have this method does this method does this. It's the parameter it takes. This is what it returns. You should be able to fill it up. So now you know it takes a student mark. There it is. And returns true. So what is your param? Final mark. The student's final mark in the course. And it is between, again, you can say 0 to 100. You've already ensured it is between 0 to 100. You don't have to do that insurance here. When you asked for it, you didn't budge till it was a mark between 0 to 100. And it returns true if the final mark is greater than or equal to 60 and false otherwise. Okay, now write the logic. What do you have to check? You just have to check what is the final mark. A normal if statement. If the final mark is greater than equal to, now magic number 60. I won't use it. So we'll call it a passing mark. So I'm going to declare another variable called passing mark. I haven't yet declared it, but I will. Remember how I have a minimum mark and a maximum mark? I'll declare a passing mark. Because passing mark is different for different courses, right? At Georgian also. In the postgraduate course, it is 60%. Undergraduate course, it is a 50%. So why not just declare it? We will. If it is greater than, I'm going to return what? True. Else, I'm going to return what? False. Notice this sweet method. I didn't put any opening and closing braces either in if or else. And they are not necessary if there is only a single statement. But again, good programming practice says always put your if body and your else body in opening and closing braces, just in case you want to add more statements, which you can argue when I add them, I'll put them. But syntactically, there is nothing wrong. If there is only a single statement inside the if, then you don't have to put braces. It's not necessary, though highly recommended. Okay. Now, what is this passing mark? And please notice this true. True and false. Again, this is for you and just to explain what it is. The two Boolean constants in Java are true and true all in small case and false. Try to change it and it will change color and it's not a Boolean variable. Right? So true and false are the two Boolean operators. So here you can, I don't know what else could I write here. The OR operator. We can say the OR Boolean operator, the OR logical operator. so that you know what these operators are. So you've done relational operators. Here is an example of a relational operator. Here is an example of a relational operator. You've done arithmetic operators, plus, minus, multiplication. And now today you also saw a logical operator. And again, they all have their precedence. So you'll say, oh, what will happen first? Will the OR happen first, or will the relational happen first? The relational happen before the logical. Otherwise, I will have to bracketize it. Okay. And you'll say, how do you know? Check up, Google it. I could be wrong, right? But it was working, so I think I'm right. Okay. Okay. So now what is this passing mark? So let's take this passing mark from here so that I don't make spelling mistakes, which I'm making a lot today. And I'm going to declare another constant here and give it a mark of 60. Again, no magic numbers in the code. And byte is good enough for it. So I've kind of used byte today, though I could have used integer and would have been fine with it. Just because I have said in my assignment too that I would like you to use the correct data types of the correct size. Okay. So if the final mark is greater than or equal to the passing mark, you return a true. That means the student has passed. And otherwise you return a false. You'll say, but do I want to say true, false in my answer? I want to say pass and fail in my answer. I'll show you how to do that. It's not a big job. You'll have to just check. Are you true? Print this. Are you false? Print this. Okay. Okay. So is my check status complete? How will I know it is complete? The only way I'll know it is complete is if I print out. So I'm going to do the display student information. I'm yet to do the grade. The grade one is a little big, and I'm going to kind of comment this out. So I'm going to write the display student information for you. I have the number of the student, I have the mark of the student, and I have his or her status. So I have still not calculated the grade because is a little more complicated in terms of if. So I'm trying to do things that assignment 1 can be done. So that you can't say, oh, you never talked about it. I could always say you were not listening, but I'm hoping you're all listening. Sometimes you do fall asleep, that's okay, but try to listen most of the times. That's why you sit in the back so that I can't see if you sleep. Okay, so it's a public method, private method. I make all my methods private because it's an application. The methods are bound to the application. Nobody in the outside world even is interested in my application. What are they interested in? The running of the application. Okay, so it's a private method. It's static. It returns nothing. It takes a student number. The student number was a string. It takes a student final mark. It was a byte. So you have to fill up the types here. The sequence is important because that's the sequence with which I'm calling. And it has a status coming to it, which is of type Boolean. What does the method do? This method displays student number, final mark, course final mark, you can say. Yet we haven't yet completed it, but when it will, then we will add that to and status. That's in the course. Right? That's what it does. Does it take any parameters? Yes, it has 3 parameters. 1, 2, 3. It would be easy if I could just take here, copy it as my first param, and everybody can see the param. When you look at the when you look at the help of this method, these params will come up. They'll show. So you'll say, oh, that's what she's talking about, or whoever has written the program. So with params, you always name the variable. With return, you never name the variable. See, I never said return. I didn't say anything. I just said return the final mark. I never said return this final mark. I never use variable names in return. Why? Because you can't see them. They're local. They're inside. But the signature of the method can be seen. And since the signatures can be seen, the params will always have names. But the returns will never have any name associated with it because it will usually be a local variable inside the method and we don't know what it is because nobody can see what's inside. This is what the user sees. The signatures of the method and this description. So it makes complete sense what it is doing. Okay. Okay, let's come here. Now let's print it out. So all we need is a little bit of pretty printing. You can use your printfs and make it pretty. Or whatever way you like. It's really up to you. The main idea is it should be neat, clear, complete. I'm assuming this is what I will need, but I don't know if I need more. I'll just kind of give more. And we'll take this. Notice how it says I don't know, because S should be capital. Oops, caps lock is on. S should be capital. So system is a class. That's why it's in capital. Okay. And system.out is a variable. It's basically an object. It's called system.out. And then the ending line. Just take the same thing so that we know where it ends. And then we'll replace this by all dashes. And now let's print out. Okay, we need to print the name, the number of the student. And again, all messages must be complete and clear and grammatically correct, guys. Okay, so let's go. Again, it's up to you how you want to show it, in a tabular form or whatever you want to use printf. Sure, let's do that. Printf. We want to show the student number, right? And again, you can do it like this. You can go in how many spaces. So let's say 20s, percentage 20s. That's for my first one. I'll put a colon and I'll put another percentage s. Again, if you want to make that too of a certain size, you can. And what do you want to print? You want to print the word student number. That's a literal, but it will print it in 20. Everything that you print will put it in 20. And the second thing that you want to print is student number, the variable student number. So the first percentage 20s is for this. This will print in 20 characters. It will be padded by blanks, I think, on the left-hand side. I forget whether it's right justified or left justified. We can double check. Okay, that's my first statement. What is my second statement? Because this will be kind of common. I know it's not all common, but the second thing I want to print is the student final mark. And again, the final mark will take 20 spaces, and the variable is called student final mark. Again, I could have changed it. I just became lazy. So the aim is not to kind of confuse you, though I said I wanted to confuse you. The aim is that you understand what you're doing. And the status. Now with status, the student mark is a D. I don't know what about status. How do you print Boolean values? I don't know. I'll have to check up. I've never heard of it. I'll try a B, but I don't think so. What's this format specifier for Boolean values? Because usually we don't print true, false. We always give something like pass or fail or yes or no. True, false is hardly ever printed. But there has to be a format specifier. We'll know. We'll have an error and then we'll Google it. What else can we do? Okay. And please remember to put a percentage N, copy and paste, make a mistake. Have to write it everywhere. I'm not sure. So if I'm not sure, the best part would be to format output Java printf formatting numeric output. No, not numeric only. Format reference page. Cheat sheet. Let's try this one. Do you see a Boolean value? I see a percent. There it is. Okay. Percent sign, number in hexadecimal, number as an integer, string of characters, octal number, integer. Oh, I can also be used. There is nothing for Boolean. I don't see it here. Let's look at Oracle then. But that's numeric, so I'm not strings converting between numbers, manipulating. That's bad of them, not even talking about Boolean variables. At the end of the day, I don't want it, but I am just curious. Converter. D. Boolean value. Okay, I give up. Just to make it run, I'll do, what should I do? What can I say? I have to say something. I mean, anyway, it will be taken care of afterwards. So I'll kind of go println for now, okay? But I have to find out. It's strange. I'll ask my colleagues, have they heard of it? Usually we never print out Boolean values, so I've never thought about it. Okay, so I'm just doing a println and I'll show the status. Then I know it will say true or false, which will look very odd. And that's why I will do something about it. Okay, let's try. So that's my display information. It will show me the student number. It will show me the final mark and it will say status, which will of course say true or false because that's what I told it to do. Let's check if it works. Let's compile it. No errors. Right click, main, will behave and give the right mark. Let's try to make the student pass. And that's what it says. So notice the first two are taking 20 characters each and it is right justified. The third one, because I couldn't find the format specifier for Boolean, but it is saying true. Now status true doesn't make sense. What would you like to see? Pass or a fail, right? So one way was the method that was calculating Boolean, you could have returned a string, return pass or return fail. That was one way of doing it. But I would like to do it another way because it gives me two things. One, I can use a Boolean variable, and two, I can use an if statement here. I'll say if the status is true, then I'm going to printf. Now I can use a printf because I know how to print a string and a string. So the first one would be good. So status and then the value of, and then you have to print status is true means, I mean, you don't even require a printf, but anyway. Pass. I'll tell you something else also. I'll show you another way of doing it. A neat way. So I checked myself. I said, if it was true, then I want to print pass. And again, I haven't used brackets, though nothing stops you guys. If you like the habit, and I am in the habit of putting brackets, but sometimes students come into the second semester and they don't know that, oh, they're not necessary. They are not necessary if it is a single statement. They did my as good. So they are not necessary. But if you want to, sure, put it. Nobody stops you here. It's not wrong. It's absolutely not wrong. Most programmers will put them, even if there is a single statement, because it's just a habit. It defines a body, right? So what it is going to now do is it is going to say status pass or status fail. Now, this kind of looks a little odd. Equal to true looks a little odd because you never say if raining is equal to true. You say if raining. Normal English, do we say if raining is equal to true? No. Do you say if hungry is equal to true? No, you say if hungry. So you can write it as without the equal to true if you want to. And again, most programmers will because it makes complete sense. You can just write it like this, if status. Which tells me I can also say if not status. Not status means status is equal to false. Now notice I didn't put another else condition here. I didn't say else if status is equal to false. That's silly. If it's not true, it is false. There is no other option. Why should I repeat conditions? So do not write unnecessary conditions here. Don't say else if status is equal to false. Like, how clear are you getting? You're confusing more than clarity. Because if it is not true, then the only other option is false. So don't write unnecessary conditions. Why? Because the user has also to check. You've given another if to check. You've said, oh, here is another if. I mean, why waste your time and why waste the computer's time? So don't put unnecessary conditions if not required. So I've said if status is true, do this. What is the other option? It is false because status is a Boolean variable. I've said if the mark is greater than or equal to 60, return true. I've not said if it is less than 60, return false, because it is by default, if it is less than 60, it is fail. So don't put unnecessary conditions. Is it wrong? No, it's not wrong, but it is unnecessary. So anything that is unnecessary is redundant. And redundancy means you are not thinking or you're overthinking, let's say. So if you would like, you can only say if status, which is how I would like to see you doing it. But otherwise, you've seen a new operator. This is called the equality operator, and this is a relational operator, right? It's checking for equality. So the assignment operator is a single equal to, though we call it equal to, but this is actually the equal to. But when we say, we don't say assign, we say A is equal to 3. What we want to say is A is assigned the value 3. Okay, so this is how you will do it. Now it will say pass or a fail. I'm going to show you something neat in a minute. Let me see if it works. So we had an input that was kind of untidy before. We want to compile it. We want to give it another go. We want, the while was already working, so we needn't check the while. This person has failed and it will say status is failed. So I'm not interested in what your input is. You will say, but you can see it and you still want us to put it back. Usually when input is taken, after that the screen is cleared and then the output is shown. Right? And that's why I'm making a habit that you always show everything in your output. You'll say, are you blind? Can't you see what input I gave right here? And then you're again telling me to reprint it. But keep in mind that's not always what happens. You take input, you clear the screen, and then you show the output. In an application, your input is gone, only answers can come, or both can come, whatever. So when I write input, when I write output, I write everything. Now this is coming on a different line. Seems like I have a print there, println there instead of a printf. And it's not wrong, but it's just untidy. So I'm going to go and look at my method, which is asking for the final mark. Oh, because there was a percentage. No. Where is it coming from? Here is where it is coming from. The final mark. It was just looking odd on a different line. Number is being asked on the same line, and marks are being asked on a different line. It was just looking odd, nothing else. We try to improve the how it looks also, right? But of course it should work. So it is working. Everything is working. Now, as I promised, I'm going to show you another way of writing this if else, just because it's interesting. I'm going to use a ternary operator. The if else can be written in a compact form. And that is like this. So you want to print out something, and that something we don't know, but let's look at that something. There is a ternary operator, and the ternary operator works this way. You can put the condition, what you want to do if it is true, and what you want to do if it is not true, all together like this. You can do it like this. And this is called the ternary operator. And this ternary operator is actually a combination of question mark and colon, and has 3 parts, therefore ternary, okay, for 3 parts. Okay, so what do you want to do? What do you want to replace this S by? You want to replace this percentage S by pass if the status is true. And if it is false, you want to replace it by fail. So see how I'm going to write my ternary operator. And I'm just going to put it in brackets so that you can read it, though it's not necessary. Okay, I'm checking the value of status. If it is true, remember I said you can just say status. You don't have to say is equal to true. But this is what I'm checking. If the status is true, I want to print pass. So the percentage S will be replaced by pass. Else it will be replaced by fail. That's the cute little if-else ternary operator. It's called the ternary operator, question mark and colon. And it is a shorthand compact form of an if-else. You'll say, can I assign it to a variable? Sure, you can assign it to a variable actually. You can do it like this, though it's not necessary. You can take another string here. You can call it what? I've already used status, so print status. Here, you can do it right here. No, that's not what I wanted to copy. This is what I wanted to copy. Oh God, no. This is what I wanted to copy. See. You can assign it to a variable. Nothing stops you here. And then you can put that variable right here. Though you don't have to do it. That's what I'm saying. You don't have to assign it to a variable. You could have done it right here. But this can be also done. So it can be done in assignment also. So I'll kind of keep it here so that you can say, oh, both ways can be done. So you can assign it to a variable. I have assigned it to a variable. Now I don't know is ternary operator bigger or whatever. We'll know for sure. If it gives us a compilation error, we'll have to bracketize it. No, it's fine. So this will happen first. So what you see on the right-hand side is an if-else. It's saying if status is equal to true, assign pass to print status, else assign fail to print status. And what am I assigning? String values. So what is the variable on the left-hand side? A string variable. If I was using numbers 1 and 2, I would put integer on the left-hand side. So look at the right-hand side. It is saying if status is equal to true, assign pass, which is a string, to this variable, else assign fail to this variable. Shall I show it to you another way where I was saying the not operator? Same thing, but in another way. What if I say status is equal to false? Then I have to put fail here and I have to put pass here. There's so many ways of writing it. Or what isn't it like? Oh, print status is already defined, it says. Of course, copy and paste. See, I told you copy and paste is not a good idea at all. Or I'm just doing it in many ways. And of course, you will not do it in all the ways. I'm only showing you that it can be done in syntactically, it can be done in all these different ways. So you don't want to say is equal to false, don't say it. But if you don't say is equal to false, then you say not status. This means fail, not. And if you don't want to say true, this is how you say true. So what did I do? I said print status. If status is true, pass is assigned to print status, else fail is assigned. Makes sense. I said you could also do it another way. If the status is false, you can assign fail to print status, else pass. Same thing, but just said in a different way. I just said it's very odd. You never say if hungry is equal to true. So instead of equal to true, you can just use the word status. This also means status true. And this means status is false. When you say not status, it means status is false. So you can put your comment for yourself. This is status is equal to false. And this means status is equal to true. All of these statements, 4 statements, mean the same thing. They'll all give you the same answer. And if you don't want to put it in a string variable and print it right here, then you can put the expression right here. The expression can be put right here. So again, I'll put it for you so that you know it can be done that way also. So there is no dearth of doing things. You should be smart enough to do things correctly. There. So let's see if I have compilation errors, then I'll put the extra bracket, but seems like I don't have any. I mean, it didn't say anything, so there. Now, of course, I'm doing the same job 6 times, so choose one. I don't want to do the same job 6 times. This is doing the same job, the same job, the same job, the same job, same job, and same job. I'm just showing you different ways of doing it. So choose whatever is easy for you to understand. But I've introduced you to a compact if-else statement, but it is a single if-else, not nested. So instead of writing if this, else this, you can always use the ternary operator. Right? And it seems ternary operator has higher precedence than this. Otherwise, we will never get an answer. So you can try it this way if you want. So comment this out, comment this out, comment this out, and comment this out. Let's see if it works. Right? If it works, then of course we know the rest 3 also work. So let's try that. Let's try that. Let's compile it. No errors. Let's run it. Let's run it. Let's give my number, my name, marks, and of course, status failed twice. 2 print statements somewhere. 2 print statements somewhere. Oh, yep. No, I only have 1 print statement. Why is it printing twice? Oh, there. There was an if here. Oh, I forgot about that if. I wrote an if and then I wrote the ternary operator. So you're seeing the answer twice because I told it to print it twice. So there's never, oh, I don't know what's happening. It's always, you should know what is happening. So I thought, where are the 2 print statements? I commented it. I did comment it, but I didn't notice that I had an if here. So again, this if status is equal to true can be replaced by if statuses. It's just different ways of doing the same thing. Choose whatever you like. To show you it works, I can remove maybe, then I'll have to put a string in front of it. I can do the opposite here. I can just say, remove this one, not use print status at all, and use this one. This will also work. All of them are the same thing. This one will also work. Let's pass the student this time. There. And of course, it is printing twice because I have those 2 ifs. Clear? So you've seen a do while, you have seen an if. You've seen the ternary operator if also by chance, just for the heck of it. You've seen a Boolean variable. You've seen a method that returns a Boolean value. You know about Boolean constants too. Okay. Now let's look at the last one. Oh, won't be able to do it in 10 minutes. One is left. The how to find out the grade, which is basically a nested if statement. So it will take a little while because it's a nested if. Instead of that, what I'll do for you is I promised you that I would write this do while as a while for you and show you the difference. Let me do that for you. Right? Let me do that. The difference between, you will differentiate between the 2. Okay, now the while loop runs like this. You write the while statement first, and then you write your while body. So now think, if I wanted to replace this do while, which I think is better in this situation. Why? Because I have to read and then I have to test. I can do this. I can say while the mark is less than 0 or greater than 100. I just want to show you that you can do it. You're doing the same thing that you were doing before here. Prompt and everything is the same. Nothing has changed. But now the big question is, if nothing has changed, why did you use a do while and a while? You tell me. You tell me the difference between the 2. Oops. Come on. Can anybody point out the difference between this do while and the while I've written? All I've done is I've put the while and the do in opposite directions. That's all I've done. But there is one major difference. What is the major difference? You say it's exact copy. What difference is she talking about? In the while, is the final mark available before I check it? Where is the final mark? Suppose this do while was not present. I'll comment it out. So I'll remove it for a minute. Don't want to, but we'll remove it. I'm going to take the do while that I wrote. Why should I remove it? I'll comment it. And I will comment it here. Okay, it's commented now. So there is a final mark variable declared. I start with a while loop and I say while final mark is less than 0 or greater than 100. And it's giving you an error right away itself. It's intelligent enough. It says, where is the value of final mark you're checking? Where is it? Because the condition is checked before the loop starts. It doesn't have a value. So now what do? You either read it once before the loop and then go inside the loop, or you give it a wrong value like -1. So the loop will always start. You have the option, right? So you can give it a fake value of -1 and the loop will start. The loop will say, oh, it is less than 0, so let me ask. But you'll have to do extra work, right? You will either have to give it a fake wrong value. Local values don't have, final mark is declared, but it has no value, it has junk in it. So you can fake it, give it a -1 and the loop will work. Why am I saying -1? Because the condition will be true and it will go inside the loop. Or you read it once before the loop and then go inside the loop. So extra reading will have to be done. Extra work will have to be done. So in our case, the do while is better instead of doing this. If you want to use this, you can take your final mark and give it a dummy value. It's a dummy value. What is this dummy value for? To make the while start. Now it will work. Final mark is -1. Is it less than 0? Yes, now it will work. It will ask and it will work. Now it's okay. But I have to do something extra. So do I use the do while loop or do I use the while loop? Because they're both checking the conditions are true. It's just a difference of how do you see it? How do you put it in your mind? With this, I have to do this extra step. I have to give it a dummy value to make the loop work. Let's see if it works. Okay, so let's try it again. Let's compile it. Now it won't complain because it has a value. So keep in mind, local variables do not have junk. They have crap. You can't use them without assigning them a value. So I assigned it a value here. You could have assigned it there, but I want to comment this out and keep my do while, therefore I put it here. But it should work. So let's compile it. The same thing will happen. It will work the same way. Go here, right click, run, run. Let's give something less. We'll ask again. Let's give something more. We'll ask again. Let's give something less. Let's give something more. Let's give a right value. We'll stop. And it still works. So the do while and while are sisters, could be brothers, are siblings, right? The difference is, as a programmer, you don't want to do any extra work. Here, because I want to enter the loop, the condition is checked at the beginning. Because the condition is checked at the beginning. So to make it work, I have to give it a dummy value so that it starts working. In the do while, the condition is checked at the end of the loop. So I don't have to use anything that is dummy because it will automatically start, right? So the logical operator and the condition is checked at the end. That's the difference between the two. So I would prefer to uncomment this because it's more, I don't know. It's up to you. I mean, I've shown you both. But to me, logically, if you have to read a value and then you have to test it, it makes sense that you first read and then check. So to me, I would like to use this one. So I'll uncomment this one. But since I've shown it to you that the other one works, I'll comment this one. And you should be able to see the difference between do while and while. So in one, I don't have to bother about because I'm first reading and then checking. Here I'm checking first. So if I have to check something, it should have a value. So I gave it a dummy value to force it to start working, and then I started asking. Okay. Sometimes you have to be. This one was easy. Sometimes you may be reading one time extra than what is required, and you have to take care of those things. So to me, the do while is more intuitive and more obvious that do while this job is true. Okay. So that takes care of being ready for the assignment. You're ready for the assignment, but you still haven't calculated the grade. That is, you haven't seen nested if statements, which is okay. We'll come back to ifs and whiles and do whiles and switch after your midterm in greater detail. But you know how to use an if, you know how to use an if else, you know how to use a do while, you know how to use a while, you know what a condition is, you know what a compound condition is, and you're okay for your assignment and your midterm. I'm not going to ask you any more than what I have taught. We'll come back again and we'll do our iterative statements again in great depth after the midterm. Okay? So you are done for Java assignment 1 and midterm when you come back. Okay? I'll put this on Blackboard for you.
So I couldn't figure out that problem. I was
Not
having.
yet? Okay.
No, but I found something else. So what I'm doing now, I made a
Valid.
boolean called valid, and then I just checked it this way, and then true or false, and it seems to work just fine.
Strange.
Yeah.
Okay,
and I
to
put my
do
while.
something. So try to put the scan next to lower in brackets.
Like this.
Yeah, and on the other side, I'm thinking that it reads first and then picks up the character, and maybe that's what is causing. But it is printing M was the main
Yeah, it
thing.
was printing
No. So that's not the problem, right? So what did you have before? Do you have that option of showing? So M
I
was
had it
the,
so the gender equals M, or gender does not equal M, or gender does not equal F in here.
so the when you did an and then not an.
And
Think about it.
so if it's
Yeah.
not M and not F, then
If it is then it is.
okay.
Yeah.
I think I got it. So my logic
Yeah,
is
the
just-
logic was wrong. Yeah.
Okay, I got
Right.
it.
Yeah, try that and
Okay.
see. Okay? Because sorry, offs, ands and ors are always
Just
kind of confusing. You have to kind of think twice about that.
Okay.
I think you need an and.
Okay, I'll try
Okay,
that.
you try that
I'll redo it.
and try. Yeah, and let me know. Yes. How can I help you?
The midterm, so it's gonna be written exam or is it gonna be
Practical.
so it's gonna be all online? Like
Yes.
okay.
Without the use of
Will there
the
be
internet.
any like review practice online before, or just we have to just look at it?
I'm doing practices every time I see. I'm doing a program every time, right? So that's what it will be.
The math quiz.
The math quiz tomorrow or day after or whenever you have it.
Yeah, that's
Yeah.
Thursday.
Yeah.
Is there gonna be any calculators for that? Or
Nothing. I won't give you anything that will need a
okay,
calculator.
so the questions on the review is like 1500 divided by 16 and stuff. We're gonna be doing that in our heads.
Don't worry, I'll take care of that. If I ask you something, you will have the resource. Otherwise, I won't ask. I'm not expecting you to know your 16 times table, neither do it in your head. So don't worry about it. Okay? I have not made questions that will need a calculator. Okay? All right.